as we have today. Now we have the third project, and now we move over to India, to Ashok Leyland, that will give us another good, interesting example here on how quality drives sustainability. So, welcome.
Sustainability is not just a goal, it's a journey where innovation leads the way. Our project is supporting long-term economic growth while protecting the environment. Pantnagar plant is spread across 190-acre area, out of which 44 acres is a garden area. We are proud first commercial vehicle plant outside Japan who won the Deming Prize in 2016. We are one of the most integrated plant among 9 manufacturing plants of India. We have a diverse product range from 19 tons to 55 tons, catering 533 solutions to our customers, offering a comprehensive selection that offers haulage, tippers, tractors, etc. This plant is not only dedicated to industrial excellence, but also emphasizes environmental sustainability by showcasing the flourishing flora and fauna inside the plant. We have a well-organized sustainability policy in place, and our project is also aligned with this policy. We have very structured and defined long-term objectives. Out of all, ESG is one of the most important objectives. We have identified projects which will help us to achieve net zero plan by 2030. First, we will provide an overview of our project. In response to government regulations, the demand for cabin-built vehicle is expected to rise in the future. To meet this forecasted demand, we have undertaken this project aimed at boosting productivity while minimizing the use of natural resources. This project is linked with 4 UN sustainability goals. So, this is our cabin process flow where cabins are being made at press shop, welding activities happen at weld shop, and then painting process followed by PTED and top coat painting. After that, the cabin trimming activities are carried out. We will be focused on paint shop for our project. To understand overall capacity gap of cabin manufacturing, we observed a gap of 24,000 cabins, although all the processes are below the target of 72,000, but PTED process was major concern out of them. Here are the details of line study of PTCD process, and we found each process is capable to produce 60,000 cabins, but our line output is not matching with process output, so other factors also need to be identified. Observation of waiting time in PTCD process. We have only 14 hangars against 18 process station. As a result, every 15th cabin waits for 18.6 minutes, which result in loss of 12,000 cabins per year. So on the basis of study, we introduced 4 cabin hangars which increase our capacity from 48,000 to 60,000 cabins, but still we need to increase further capacity to reach our final target, that is 72,000 cabin considering the future plan. Considering our final target of 72,000 cabins, we migrate from 3 mile to 4 mile with line balancing, and we found all processes are capable to produce 72,000 cabins. That is, their capacity increased from 60,000 to 75,000. But now PTED and top coat become the next bottleneck. Then we further studied our PTED process and found there were 3 bottlenecks. First, degrees 1 and 2. Second, phosphate. Third, CED. To overcome these bottlenecks, we have 2 methodologies. First is to optimize and second is to upgrade the existing technology. Methodology first, phosphate process. Same we validated through statistic tools and found processes direct relation with coating weight and SSTRs. From main effect plot, we can see when we reduce the process time, that is the SSTRs, coating weight reduces. So changes in current process is not feasible and we have to go for other option like technology upgradation. So we conducted multiple trials to reduce the cycle time of bottleneck processes, where we found reducing process time in current setup is not feasible as all input parameters are impacting the cabin quality. For technology upgradation, we generated 22 options through Gamba observation and solution metrics. We come with 3 options. Option 1, outsourcing of the SPD and VOR parts. We observed that our costs were increased by almost 3 times and it also introduced defects due to multiple handling, so we dropped this option. Option 2, double cabin process in the PTED process. We have benchmarked with our Hosur 2 plant. We checked the available space and found available space is not sufficient for double dipping, so this option was also dropped. Option 3, through upgrade of PT chemical and CD paint to reduce the cycle time. In this, we identified the scope of this project where we found if we can reduce our process time from 180 seconds to 120 seconds while maintaining our output minimum 8 micron DFT in box section area. As we know, in our degreasing process, we need to remove or clean the oil from the cabin surface through surfactant process. If we increase the reaction of the surfactant process, then we can reduce the process time. Phosphate is used to make the intermediate bond between the sheet to paint film through the help of coating thickness. If we reduce the coating thickness, we can reduce the process time. In cathode electrode deposition, if we reduce the DFT variation from outer and box section by increasing the throwing power, through that we can reduce the process time. Because of specific Ashok Leyland requirement, we worked out with our chemical and paint suppliers, and out of all the suppliers, there is only Nihon agreed to develop PT chemical and consign Nerolic paint for paint. On the basis of our specific requirement, Nihon proposed us for upgraded chemical, through that we can reduce the process time by 60 seconds. Here you can see the comparison between the existing chemical and the proposed chemical. Environmental and technical benefits of the proposed chemical is also listed on the slide. On the basis of our specific requirement, KNP proposes upgraded paint, through that we can reduce the process time by 60 seconds. Here you can see the comparison between the existing paint and the proposed paint. Environmental and technical benefits of the proposed paint is also listed on the slide. After getting proposed paint, not only development, we also ensured validation at multiple levels. First level at supplier end, validation at manufacturing facility, and validation at our product development team, that is at MED lab. These are some glimpses of validation at supplier end. Then validation at Ashok Leyland Pantnagar lab. And finally at MED lab by product development department. In similar manner, we checked paint at all three validation levels and found paint is okay in all parameters. First validation at supplier end, followed by Pantnagar lab and MED lab. After completing all validation, we mapped the possible risk and their mitigation plan. So our risk number 1 is cabin may dry in decreasing process as process time is reduced and surfactant reaction is fast. Earlier the spray was getting started after the cabin was completely immersed. To mitigate the dryness factor, we started the spray before the dipping of the cabin, and spray gets stopped when the cabin is completely out. In CED process, we have two risks: low DFT at box section area and safety considering the same speed being used in bend area too. To mitigate this risk, we conducted design of experiment DOE. Here in DOE, input factors are EMS carrier speed and cycle time. Response section is box section DFT. Then in the DOE, we found speed and cycle time is the significant cause. If we put the carrier speed at 11 and process time is 120 seconds, we can get the required DFT on the box section area. After all validations, we introduced all updated chemical and paint in our line. We are proud to say that the supplier developed the paint and listed the product on the name of Ashok Leyland. This is before and after scenario which indicate how the temperature reduced from 140 degrees Celsius to 130 degrees Celsius. So after complete execution of the project, we finally achieved the capacity of 72,000 cabins per year, and now all the processes are capable to meet this target. After implementing all these projects, our capacity reached at 72,000 cabins per year, and also we reduced the carbon footprint by 54%, overhead cost by 45%, water by 10%, propane consumption by 25%. As a summary of benefits from this project, the amount of energy saved by us can light up around 1400 houses. Also, the water saved can be supplied to more than 1800 houses. Now we are ready for nano coating, which can meet the European standard. Not only this, as a byproduct of this project, we also saved approx 1.35 crore rupees. We checked the process capability and observed the CPK value is 1.54 and our defects also reduced by 59%. All short-term and long-term quality parameters are within the range. We demonstrated it to all Ashok Leyland plants, and horizontal deployment is in progress in Hosur 2 plant. This is our future plan where we are going to replicate this technology for our upcoming product range at plant. As a learning of project, we will conclude our presentation with a quote: "Money is yours, but resources belongs to nation and society. So utilize them wisely and innovate towards sustainability." Thank you.
Thank you very much for the interesting presentation. I think Mr. Namit Rausch is going to answer the question. Hello there. Nice to see you guys. Jose Carlos, you raised your hand. You have a question?
Yes, please, Willie. First of all, congratulations on your project. When you described your project objective and description, you identify four UN Sustainability Development Goals. And the first one you mentioned is quality in education. During your presentation, I did not find the emphasis on how you impact this goal. Can you please elaborate a little bit more on this?
Right, sir. First of all, good evening from India. The UN objective which you talked about, that quality in education, there were two perspectives behind choosing this as a linkage with the UN sustainability goal. One important thing is, while we were working on the sustainability project, we need to get the sustainability knowledge before working on this front. So the entire knowledge which we gained in terms of sustainability, that was one of the part of it. Secondly, when we completed this project, so as a part of learning and sharing at several forums like ISQ and IAQ is one of them. So through these portals, we are sharing those learnings of sustainability as a part of quality knowledge on this UN sustainability. So that's what we are meant to say.
Thank you.
Okay, so you're really basically talking about the education within the company, but also explaining what you have done outside of the organization.
So since we are a Deming plant, so this is our this is our responsibility to exchange this knowledge with other organizations, not only about the automobile, in fact, to any of the organization which is, focusing on the sustainability. So at several national outsider front, we have shown this project also, and we got so many information exchange with other organizations as well. So that is why we said we are connected with the quality in education.
Okay, thank you. I have another question, which is maybe a little bit more technical, because I wasn't 100% sure. The paints you are using, are these solvent-based or water-based?
The project is related to the water-based paint.
Okay, that was an important point for me. Any other questions from any of you? Mr. Nahari, go ahead. You're still on mute.
Just knowing regarding your design of experiment application, if you can put up that slide, I can ask you.
So I may not be able to share that screen on this particular laptop, since Zoom is not our regular,
Understood. But my curiosity is, what kind of design were you using in the design of experiment? Is it a full factorial design or a fractional factorial? Any knowledge on that? Or is it a central composite?
I will try to put that slide on the screen also.
Yeah.
Well, I think if I saw it correctly, it was a two-factor, two-level design. Yeah, so it's almost bound to be a full factorial, I think.
Full factor.
Yeah.
I'm sorry, I cannot place that slide on the screen.
Not an issue. I think sir clarified, no problem.
Okay, if there are no further questions, thanks.